And right now, that angle is here. And this is going to represent how many coils. I'm going to make this drive coils. So I'm going to start with, let's say, 7 coils. Okay. Let's just move this. This is representing a number of coils. So I'll check that. And I'm going to show those dimensions again. And I'm going to call this coils. So this angle is defining coils. So the angle, so if I have 7 degrees, it's going to equal 7 coils. So I'm going to call this the coils. This represents the total coils, not the active ones. The active coils are going to be the ones that are not touching. So you're going to have to subtract the coil. We'll be doing the math on that. The closed ends, the wires that are touching are not active. We're only going to do calculations for the active coils. So between here and here, that's the only ones we're going to do calculations for. Next, I'm going to need the grind angle. Let me turn my planes back on. And let's regenerate just to make sure nothing changed. Something did change. Oops. Okay, maybe I shouldn't have regenerated so soon. Okay, so I need something to represent the grind angle. I'll show you how this works. How we're going to do this. Yeah, I'm going to need to go ahead and put this grind angle in. So what I'm going to do is I'm going to select this plane right here, datum 1. I'm going to sketch another curve on there. And then for references, I am going to remove everything. That one I'm going to keep. I'm going to remove that one. This red one here. Delete that one. And then I'm going to select this curve right here, the end of that curve. I'm going to right click and pick from a list because I want to make sure I get the end of that curve. So here it is, end of the curve. That's what I want. The one is lighting up. That one. That one's that line. That line. That line. So that one there. It's going to be my reference. And the reason why I'm using that is so I could draw a circle. So the idea here is, oops, I should have kept that one. I should have kept this one as a reference. Sorry. So what was I doing? Okay, circle. I'm going to put it at the intersection of those two, the intersection of those planes. I'm going to let it snap to that point. That way the circle has no dimensions because I want to no extra. I don't like having any dimensions that don't belong in there. So to avoid creating dimensions, do stuff like that. Line it up to things and whatever. But my grind, if I go to sketch view, I'm going to turn this around so I can see. Let's see if I can see this. My coil is right there, so I need to grind from here around to here. So I need to draw a line. It's going to go from here around to there. So I'm going to draw a line from here out to this circle, and that's going to define my grind angle. And we'll get to that. I'm going to set it initially for 280. So there's my grind angle. And I'll show you, we're going to do that. We're going to do that in a minute. We're going to go ahead and put that grind angle in. I'm going to need this to go before the helical sweep. Put this before it. Okay. So I got those two together. I'm going to make a group out of those later because these two sketches are actually going to have all my nominal dimensions in them, just these two sketches. I'm going to create another one later, but that's not for the nominals. These two dimensions are going to create all my nominals. So let's go back to our relations again. So now I could unrem this and unrem this. So now these are active. So now I could calculate the TD, where these points need to go. That's why that helix was failing. And the rough length. Verify. And what happened when I verified it says I have a grind angle. Oh, I didn't name that material. So let me just cancel out. I forgot to name the grind angle. So here's the grind angle. Properties. I forgot to call it grind angle. Okay, now if that's been properly named, we can go back to our relations and try again. Unrem. Unrem. It says the relation still has an error. Okay. It says it contains an incompatible unit. incompatible units. What happens here is because the coils, this number of coils is an angle, and I'm multiplying that against a something with millimeters and then subtracting. So I can't. There's these units of this compared to the units of this. This is millimeters divided by degrees, and this is just millimeters. So you can't subtract something like that. You can't. This is not going to work. But I'm not using my angle as an angle. I'm using it as a integer, or as a real number rather. So I'm just going to go ahead and select here. It says sensitive. I'm going to turn sensitivity off and see what happens. And now I get a OK. Now it's saying everything is OK, that these numbers make sense now. So the gray material, check its value right now, because I think I set the grind. Let's see what I set the grind angle for. I think I did 280. Yeah, it's 280. And the grind material is now going to be 0.7. Yeah, almost a little past 3/4 of a wire diameter. So this looks correct. Let's see what the rough length. Let's see, our overall length is 9. Let's see what a rough length is. 9 point. Yeah, that's about right. Because we got 290. We got some wires sticking out now for that. We need a little bit more on both ends for the grind, because I did do a grind calculation. So they're not half a diameter away anymore. And then TD is going to be the rough. I think we went through this already. So now we know our locations for 2. Location underscore 2, and that's going to be a wire diameter plus TD. So that's where that location needs to go. Oh, I see an error already. That's why the spring failed. I got location 4. It was a wire diameter. It's laying out right on top of location 1. That was my mistake. It should have been location 4. It should be minus a wire diameter. It should be the rough length minus a diameter. So I'm just going to copy and paste. That's why the spring failed. So Control C, and we go down here and we'll paste it right here. Control V, and then minus a wire diameter. So location 4 is minus a wire diameter. Location underscore 3 is going to be equal to the rough length. I'm going to just paste that, and it's going to be minus a wire diameter, and it's also going to be minus TD. I always on my parameters are always uppercase, so I could read when I'm reading this. I know that the lowercase or dimension, uppercase is a parameter. So that's my formatting. I always put spaces between the equals, and then on my math, on my plus and minus, I always put a space in front of it to just leave a little gap there. That's just my preference. So now that I got all that, I could just delete this stuff. We still have to do some calculation for the pitch, but let's see what happens. Go ahead and clean this up a little bit. Okay, so this is a transition distance. Everything looks great. Check mark. Everything went. Select OK. And regenerate. And we got our spring back, because that makes sense now. Okay, so now I'm going to go ahead and because I'm going to show that grind angle, and I'm going to set that grind angle right now. Oh, I won't. I'm just going to cut the spring first, and then I'll show you. I'll illustrate what I'm doing. So to cut the spring, I'm going to select this plane and extrude, and I'm just going to use that profile that I drew, that rectangle that I drew, to cut the spring. So I'm just going to use project. I'll pick them. This one, this one, this one, and there's another piece hiding behind this line. That one. Close that, and if it lights up, you did pick it, so it's all lit up. That's what we want to do. Select OK. And what I've got here, let's go back to a shaded mode. I want to remove material, and I also want to remove all materials. So I'm going to say through all. In that direction, I want to remove it through all in the other direction too. But I don't want to remove the inside, I want to remove the outside, so I'll select this arrow here and click it. So everything outside of that rectangle is going to get cut. That's what I want. Let me color the spring up. Let's pick something. Pick the entire spring is going to be that color. So that looks good. And now for the ground ends. I'm going to paint the ground ends so I could see them. Let's try to pick something white here. I think this one might be, I can't tell. Blue ice sounds good. Yeah, it looks good. So that's our grind angle. So you could see right now it's going from here all the way around. Now you can't look at this end. We don't have the correct number of coils in yet. But over on this end, it's always going to be correct. So right now our grind angle, as you could see, there's our line that we drew for our grind angle, and we've got it set for 280, I believe. So if I edit that, right now it's set for 280. So if I want a 290 or 300, I'll do 300. You see my grind angle. You see that flat, that piece of the material that was moved off. So I'm just going to go ahead and set it. I like 290 myself, so I'm going to put it at 290 and regenerate. So I got that. So that's controlling that grind angle. That's how that grind angle controls our grind. And it doesn't look right over here yet because we don't have the correct number of coils in there. It's all filled. We got to get pitch points. We got to get the pitch values. Okay, now to explain how we're going to do that, let me just open a Word document. Okay, just to review what we got so far, this way what we have these 6 pitch points, 1 through 6 here, and these 4 locations. So the pitch points are at the start and the end, and then there's 4 locations in between. And we've got the calculations to locate where these points go. Now we just need to find a pitch that we're missing. We're missing the pitch at point 3 and 4 here. Now just reviewing the average pitch between the coils. I know the distance in this example is 9. I know the pitch at 1 at the start and the pitch is 5 at the end, so I could calculate how many coils with this equation. So how many coils do we have? Well, we're going to ignore in our calculations, because the closed ends don't move, we're just going to remove those from our total coils and just calculate what happens between points 2 and points 5. So the only thing missing from our calculations is knowing what the pitch is. We gotta find out what the pitch is between points 3 and 4. To do that, we're just going to use what we know about the pitches between points 2 and 3. That's going to be an average pitch because point 2 is a wire diameter and point 3 is an unknown pitch. And we know the distance, and we could calculate the distance between, for the active coils, we know what that distance is. We could do those calculations. We have those numbers. The only thing that we don't have is the pitch. And note that C1 is the coils between 2 and 3 and 3, 4, and 5, so we need 2 of those. So it's going to be 2 times C1 plus C2 is going to be the total coils. Total active coils will be C1 times 2 plus C2. So we're given the average pitch at points 2 and 3 is W plus P over 2. And these are our constants that we know. And there's our calculations for the coils. So the coils between 2 and 3 is just the distance between 2 and 3 divided by the average pitch of points 2 and 3. So it's T divided by W plus P over 2. And then the same goes for coils between 3 and 4. The distance divided by the pitch. It's the unknown pitch. We don't know what the pitch is. But now we have two numbers. C1 and C2 is the total coils. We know what that is. So if we set A to be the total coils, total active coils, so we can see that coil A equals 2C sub 1 plus C sub 2, and if we do the equation, do the math, simplify, and next line we're just simplifying this equation until we get down to here, and we see that this we put our like terms together, and we can see that the term in front of the P is just simply AW minus 4T minus T, which are all constants. Those are all known, so that's just a constant. And then minus DW, and both of those things are known, so that's a constant. So if we let B equals that just for simplification, and let C equal dW, minus dW rather, we could plug that in and we get a quadratic. And then all we have to do is solve for that quadratic equation to find the pitch. So let's do that. Okay, so now that we got all those calculations figured out, how to do those calculations, let's go ahead and paste those into our relations. Let's go to our relations, and I'm just going to paste them. It just saves time. Let's paste them so I can see right here what we're going to need. Okay, so what we're going to need, what we're adding here, I'm creating this one on the fly. Distance 3 and 4 on the fly is going to be a real number. It's going to be equal to the distance between 3 and 4. It's going to be the rough length minus the 2 wire diameters minus, we're talking about 3 and 4. So those points that were here and here. So if you do the math, this is what it works out to be. The wire diameter minus 2 times TD, which is up here, calculated up here. Now here's where we're going to get into our quadratic. So I'm going to set A equals to the A is the total coils to total active coils. So I'm going to have to subtract 2 because I've got 2 coils that are not doing anything. The 2 closed ends are not doing anything, so I'm going to set A equals to coils minus 2. And B, we're just going to plug in all this stuff. The wire A times the A is up here, times the wire diameter, minus 4 times, just like in our equations, I'm just pasting it here, and then I'm going to set C equals minus the distance between 3 and 4, multiplied by the wire diameter. And the pitch I'm going to create on the fly, by the way, A, B, and C are created on the fly, they're going to be real numbers. The pitch is going to be, here, the quadratic equation. So we've got the minus b plus the square root of the quantity b squared minus 4ac. This is all over 2a. And let's just check them. Everything worked out. So now we need to paste our pitch point. We got pitch point 1, pitch point 2. We're missing 3 and 4. So we're going to go down here. Pitch point underscore 3 is now going to be pitch. Pitch at point 3, I'm sorry, is going to be PITCH, the one we just calculated. Pitch point at 4 is also going to equal the pitch. That's what we have. Delete, delete, okay. Let's get rid of these spaces. Makes it easier to read. So check on that. Everything seems to be working. Don't need to see these parameters anymore for now. So there's all the equations we need to create this spring. I think we have everything in there. We're ready to go. Let's go see if it works. Let's regenerate. As you can see, it looks like it's working because one thing that's a big clue that's working is these surfaces here, these end surfaces of that coil are on the same plane. I got an even number. If I go to my sketch here and look at the coils, if I switch dimensions, if I want to change the number of coils, right now it's 7. If I want one less coil, I'll just make it 6. Now I have 6 coils. Let's see if we have 6 coils. I'm going to regenerate because it should be exactly 6 coils. So let's count them. So from here to here is 1, 2, 3, 4, 5, 6. 6 coils, and I'm chopping off a lot of the last 2. So everything looks like it's working. It all should be driven by this curve. So if I want to change the outside diameter, I just double that, say. And then I want to change the height. I'll make that, say, 20. And the wire diameter, let's make that 1.5. I'm just flexing the model to make sure everything works. So it looks like everything's working. I regenerate, get no errors. And that looks like a pretty good spring. So now let's clean up a little bit. I'm going to call this the grind. So I'm going to just rename everything, just GRIND. And this I'm going to call coils. And this I'm going to call profile. And this I'm going to call grind angle. Now because I want all of the dimensions that can be changed to light up all at once, I'm going to select these two, right click and group them. Okay, so there's a group now, and I'm going to call that group nominal dims. So those are our nominal dimensions. So anytime I want to change anything on this spring, all I have to do is change nominal dims, and I'll get everything lit up. So I could change the height, the outside diameter, the coils, the wire diameter, the grind angle. So every dimension is changeable right from this one feature. So there we have it. That's our spring. What we'll do now is we'll add flexibility, and we're going to also add a readout to tell the spring, to tell the user how much force is being exerted by the spring in the assembly, because it's going to be different. You know, it depends on how much it's compressed. So we'll need to add a parameter called rate, and we're going to have to do some things. I'm going to demonstrate some things we can do to make this a very user-friendly spring. In other words, if you're going to copy this, I want to make it easy to copy, because the only time you're going to change these nominal dimensions is when you're creating a new spring. So I want to make this automatically set up itself, and I'll show you what I mean in the next part. Okay, so what we're going to do now is a few advanced things for this. Is we're going to create a couple of features. We're going to make this part display what force is being generated at the assembly level. So right now it's uncompressed, so we're going to maybe make a message on here saying uncompressed, but we're going to need to create a parameter, a string parameter. Let's go do that. We're just going to call it MSG. That's going to stand for message. We'll spell it out. And we're going to make it a string. And we'll just put it at test, just to give it a value. And now what I'm going to do is create on that same sketch plane that we've been using. Let me turn these guys on. Let's see, Control D. On this plane right here, we're going to sketch our, we're going to go to the engineering tab and do a cosmetic sketch. So what I'm going to need to do is reorient this. I don't want this sketch to be on this orientation, so I'll just reorient. Instead of rotating the text, I'll just reorient this, and I'll just say that this is going to be the top. So I'm going to place the text down here. So select the text. Let's pick a point, go up. Instead of entering the text manually, I'm going to use a parameter that we just created called message. Let me see here, right here. Message. I'll insert that, and now you can see it says message, and our message was test. Okay. Now, as far as the location for this text, I want the horizontal to be centered, and I want the vertical be from the top. And remember, I said I don't like any extra dimensions. This is an extra dimension to me. I don't need that dimension. So what I'll do is I'll just make it coincident to this reference here. Now I got rid of that dimension. And this is going to be my text height. I guess I'll leave it alone. We'll change that later. We'll drive that in the relations. So right now I'm good with it the way it is. So there's our message. Now I want that message at the next higher level to display the value of the force that the spring is exerting. Okay, Control D. So what's going to happen is if I'm going to have to know what the nominal height are. What is the base height? Well, I'd have to create a parameter saying that. I'd have to create a parameter saying, well, we started at 10 mil. I think, what do we got this set? Right now we got it set for 20 millimeters. So our base height is 20 millimeters. So I'll have to create a parameter and set it to 20 millimeters. That way I can compare this number to the base height, and I can get I can find out how much it's compressed, multiply that by the rate, and I can get a force. But if I don't want to create a parameter, I can do it another way. There's a little trick that I use. Regenerated, and I'm gonna create another datum curve. I'm gonna create it on datum 3, sketch it, and it's just going to be a line, and this line is going to be the height of the spring. That's going to represent the height of the spring. Okay, so we got the height of the spring. I'm going to rename this. I'm going to call it, rename the dimension. I'm going to call this, you know what, I don't like where it's at. I don't want it to be inside. If I redefine this, I'm going to move this up there so I can see it. I want to be able to see this number when I'm editing here. I don't want to dig down in there. So when I go edit, it's right where I can see it. Click on it, go to properties, and this is going to be my height. This is going to control the height of my spring. Okay, I'm going to use that to control the height of it. And how I'm going to do that, I'm going to place it as my, before all the geometry. Did I regenerate yet? Okay. Oh, wrong place, up here. So it's right after the axis, before any geometry is created. And just to emphasize something, I'm going to rename it. Let me just click on it. I'm going to call this do underscore not underscore edit. There we go. So that curve is going to drive the height of my spring. So I need to modify the profile. I'm going to go to edit the definition. Okay, so there's the definition. So I'm going to have to delete this. Now I need something to drive. I told you that curve was going to drive it, so I'm going to have to go find the end of that curve. So my references, I believe I put that curve way out here. Let me turn this stuff off. Oh, there it is right there. The end of that curve. I don't know why I put it so far out there. So now that I have that, I can make those coincident. So that this curve, I'm going to actually have driving the geometry. So I'm going to make this curve flexible. So that curve is actually going to drive my geometry. But I'm going to want, when they click on this sketch, I want them to be able to set nominal length. So I'm going to create another line here. From here. I'll just put it over here somewhere. And that's going to be the nominal length. So when I go to edit that, I'll change this and make this properties nominal. Nominal height. Okay. I don't like where that's at actually. I gotta regenerate. Let me pull that out. Like I said, I want to see this. When I go to edit this stuff, I'm going to put the other one back inside so you can't see it, but just when I'm editing, so you can see that that's not the nominal height. But we're gonna do relations. Relations are going to do this for us, and this is just so we can display this message here. We can compress this spring without changing nominal height. Nominal height shouldn't be changed. The nominal height at next higher level shouldn't be changed. It's nominal height. So what we'll do is in our relations, we're going to create a new parameter. Let's go to relations, and we lost the height. So it's saying D0. D0 used to be the height. So let's put that in there. That is going to be, let's see, did I get it here? Height. So D0, if I just highlight it and just like that and click on height, now I got it. Now let's check our dimensions. Yeah, we had to get rid of that dimension because, like I said, we're going to do it a little bit differently.